Okay, let's quickly review BIM approach. Okay, BIM approach, building information modeling approach. What is the difference between from geometry-centered approach we have walked through before? Okay, again, some quotes in architectural design. They all say something about space, empty space, okay, void space, untouchable. But actually we design space, but we not design space, okay? For designing space, we need to make boundaries, okay? In other words, in conventional CAD systems, two parallel lines for wall object, actually not wall object, wall drawing, okay? And arc and 900 millimeter lines representing a door, because there is a symbol of door object, okay? So instead of walls, windows, doors, ceiling, slab, column, furniture, space, we draw something, okay, on top of 2D. Even if it's 3D, just geometric shapes, okay? So take a look. Architects, they mentioned we are dealing with the spaces. But remember what you have done when you design. Space is void, empty, untouchable. So we made some parallel lines, symbols, notations, bunch of polygons, surfaces, instead of real objects, including space object, okay? But in Revit, in BIM tools, there are such objects, no such geometric points, lines, edges, faces, and so on. Okay, that's one of the fundamental difference between geometric approach and BIM approach. Okay, that's why I showed you this one before. Two representations are not just simple difference between 2D and 3D. This one can be 3D, and even BIM model can be 2D. Okay, that's okay. But this one is office labeled polygon. Okay. No information. This is just geometry, mere geometry, or so-called dummy geometry. But in BIM tool, there is space object. Its name is office. Space name is office. This is label, title text is office, okay? Entire geometry we created before is one tiny subset of the information set. Okay, but actually the information set, look at this, it's never ending. In other words, open-ended. So far, there is specific definition, okay, defined by someone else, ISO, some industry people, some developers. But you can add anything, okay, it's open-ended. Take a look, geometry-oriented approach. Vertex, edge, face, polygon, surface. But in BIM tools, we approach building design using this hierarchical structure, the same as designers and architects are doing, okay? Site building, floor space, space group, and structure, okay? The structure for physical, tangible, and something specific components, okay? Of course, there are some physical and tangible components, but those are some topological, hierarchical, conceptual elements, but they are still in the structure of the BIM. So that's why I showed you this one before. This is the data structure of IFC. Total 653 entities. Entity means one single rectangle box here. Those are just my example, okay? Just 20 entities just listed. How about 610 more boxes, entities? They are all about buildings in very complicated data structure defined in computational model for building. Anyway, my point was IFC site, building, building story, space, space group, and element, building element, and building structure. All they are defined and very, very well defined, well structured in computational model. Why? Simply because computer deals with buildings for human in very scientific and well organized and without any ambiguity. Okay, that's why this structure is really complicated. Actually, this one also has point, vertices, edges, surfaces, knobs, curve, and so on for handling geometry. Okay. Anyway, this is very distinct feature of BIM approach. And also take a look, data modeling example. Data model, we have object, okay? What is object? Building is one of the object, the bigger object. Floor, space, how about column? How about window? Or just mechanical system, lighting system, or floor material, whatever, okay? They are all objects. And the attributes defined under each object means property. Property and attribute, they are all same, okay? So what kinds of properties? I told you, it's open-ended, okay? Some of them are sort of predefined, user input, okay? For example, space name, you have to type space name when you model space, but mostly sort of calculated, auto-generated, auto-related, and so on. So what if we have amount of information we have? For designers, they can use such information for better design. For contractors, they can use some construction-specific information for better construction. How about managers, facility managers for maintenance? They can reuse given information such as space name, space area, and energy efficiency and occupancy time, and then facility manager can make a plan for saving money, okay? Saving electricity, saving heating cost or air cooling cost, and so on, based upon given information. Who add information? Architects, or even managers, or computers, okay? Computer can generate some auto calculation, such as area, height. We don't need to measure area or height. Revit knows exactly calculated space area and space height and related walls. How many windows this space has, okay? It's automatically detected by computers. Also adjacency or circulation, whatever. So BIM is the way we should go, okay? It takes advantages of advanced computing technologies, and it enables us to focus on design, not computing. I show you some quotes, okay? Architects, designers, human beings, main interest is what is good building, what is good environment. Their interest is not on computing itself, okay? Computing is just a tool. But in CAD system, you have to know how to control surface, how to control vertices for my beautiful knobs curve, how to edit editable poly. That was your concern at that time for 3D Max SketchUp, how to make these copies in automation. But that's not about design. That's about computing interface, computing techniques. But in BIM tools, you can keep more focus on design, okay? Not unnecessary techniques. So this is advanced and cutting edge technologies you can use, okay? So actually I showed you a lot before, computing tools, computing technologies. Let's take a review, another review using homestyler.com. I introduced you this one even when you were freshmen, okay? So this iPad or any smartphone or smart tablet application app is very easy to use, okay? You can decorate your room or you can plan any single house, whatever. This is PC version. What you need to do is simply drag and drop and put the dimension, numbers, and place furniture, windows, and so on. Take a look. This is Homestyler web version. This one doesn't require doesn't require any plugin or ActiveX installation. This is just running on top of your any browser. So take a look. This is 3D view. If you click this door, and then this one pops up information, size. Very simplified attribute, property that I showed you before under the object named door. Under this information, this one shows you double entry door, cherry color, and its dimension listed here. In other words, this is a door object, not door-like geometry. Again, this is BIM tool, okay? This is BIM tool, not CAD system. So, thanks to this BIM, simple BIM tool, this one can export AutoCAD file and Revit file. This one can be exported in this AutoCAD file. When you click this one, door geometry, information doesn't show anything about door, okay? Because AutoCAD doesn't know this is door. Only it recognizes layer name, layer type, line thickness, lots of things about position X, Y, Z, and Cartesian coordinate system, and something miscellaneous things. But when you export that into Revit and open in Revit and click this door, this one knows double panel door and associated information. But bunch of things are missing because original source of this one was Homestyler, which is really simplified BIM tool. So you can add more information. You can edit, delete, doing something. It's a BIM tool, okay? That's different system. So according to your design process, your idea should be abstract, okay? Abstraction. You need to represent your idea because that idea is invisible, okay? You have to say something in your oral speech about your idea, your design, and then it's going to be represented, recognized by others. But we have our own standard, so-called industry standard. What is our domain's industry standard? They are floor plan, elevations, sections, axonometric, isometric, okay? They are all our industry standard in building industry, AEC, FM industry. Sometimes this kind of bubble diagramming, hand drawing, sketching, and another hand drawing for generating those industry standard, even 100, 200 years ago, okay? So those architectural symbols are our industry standard. So all this process was conventional before computers, but nowadays we use computers. So at the beginning of computing, we used computers for what we have drawn, okay? For drawing. We use computers only for drawing. That is why AutoCAD, SketchUp, Rhino, 3D Max, they all about design visualization and drawings, okay? This is a geometric line object, not door object. But now we're gonna deal with Revit. We're gonna handle BIM tools. In BIM tools, this is door object. It has dimensions, parameters, as well as geometry. Computer doesn't know this is a door, okay? This is really important, distinct feature of BIM tool. Only BIM authoring tools can draw this door, not by general CAD tools for jewelry, textile, machine, and so on. In other words, this is building information modeling tool. Using SketchUp, you can make some fashion design, okay, automobile design. Even you can design space shuttle, okay, 3D Max, game characters, whatever. But using BIM tools, there is no way to design automobile or aircraft or any other type of vehicles or products, okay, only for buildings, because it's literally, as it means, building information modeling tool, okay? That's another big important distinction. our focus was on geometric shape when we use computers at first. But smart people think about, for building design, we need something smart way, okay? Computing technologies are growing and human demands also growing. That is why this kind of advanced tool introduced 30, 40 years ago and realized around 10, 20 years ago. And now you are learning this tool. And in interior design industry, so far, very few people know this, but in near future, you're supposed to use this kind of tools. So far, you have learned this area, okay? Vertex, edge, face, shell. Using what? Modifiers in geometric tools, such as editable poly or bunch of complicated modifiers predefined in 3D Max, Rhino, SketchUp, plugin, and so on. All geometry centered, okay? Some parameters, something advanced, but they are still geometry tools. But think about this part, okay? BIM, parametric modeling. Last week you saw Revit has building project, okay? This is project. What is family? What is object? What is part? This is one simple example of a part. Part, component, family, object, they are almost same, okay? Those things separately designed, defined, and loaded into your project. So adaptively applied for your design project, okay? So this is even smart way, okay? You don't need to take care of complicated geometry when you are modeling, building, okay? If you want to control this geometry, you need to go back to parts editor, so-called family editor, okay? So now we're going to take this approach in actual lab exercise. We have learned solid modeling, parametric modeling regarding building information modeling techniques, technologies. So why we need such technologies? Why we need to use parametric modeling, BIM tools, BIM technologies, and so on. Let's take a look some non-uniform design of building cases, okay? So those are building designs recently suggested by architect or something realized and mostly still under the development or some ideas only. But anyway, two different ways. It's kind of egg or chicken problem, okay? Based upon human demand for realizing those freeform buildings, parametric design approach has been growing, okay? That's one approach. Another one is, thanks to BIM technologies, design computing, advanced skills, techniques enabled us to realize this type of shapes, this type of buildings, okay? So I'm not sure what it is, but anyway, one thing clear is that making shapes from fundamental primitive geometry is exactly same to the way of solid modeling and parametric modeling, okay? So it's inevitable trend, okay? Non-uniform, freeform design using parametric design, parametric modeling techniques, and BIM. Take a look. This is one of the preview of Busan, Haeundae, okay? Nowadays, we design building exterior, building skin, building surface, facade, using very complicated structure with very organic shape, okay, non-uniform shape. That's inevitable and kind of trend, okay? Let's take a look at inside of the building. This is Dongdaemun Design Plaza, okay, DDP. The inside of DDP. This building has very curvy and non-uniform shape exterior. Of course, that is why this kind of banded, angled columns or some rounded ceiling, window structure. Everything in this scene kind of non-uniform except flat floor. Okay, for safety reason, of course, floors supposed to be flat, but anyway, very organic shape. Take a look this stairwell and this rail structure and the wall structure. Very organic shaped, okay? How about this one? This is one of the interior design project done by Professor Jang. Jay is working, Mire Medical Center. Take a look this structure. This one is okay, and this building, of course, box shape, modern style building. But inside of this building, there is something like this, very unique structure, okay? Non-uniform, freeform, organic shape. So this one, upstairs, stairwell to upstairs, and the other side we can design in this way. So this is one tiny example of some unique design features of interior design. Even if building shape is very simplified using box shaped, anyway, this is an inevitable trend in current built environment design. Let's take a look some more cases, but totally based upon parametric modeling and BIM approaches. Okay. Beito Building and Korea Navy Museum and Plaza Hotel remodel. Take a look this Beito Building. This one located in Garosukil. Okay, very expensive area, and a lot of passengers, lots of young people surrounding this area. But this is, take a look, this building. This is remodel project, just box shape, modern style building, nothing unique except building facade. So the owner of this building interested in how to make this building kind of attractive for people. There's only one way, okay? This is already box-shaped building. So building facade design alternative can make some distinction from other regular buildings. This is Revit model, okay? Using Revit or BIM tool, this kind of alternative building facade, building skin, curtain system can be designed quickly, easily, and the same as built. This is picture, okay? Take a look, same. Because this BIM model in Revit supposed to be real structure and all counted, okay? Components, parts, mullions, frames, this curtain system for entire material or detailed features already predefined in design stage, okay? So this one realized in this way, totally same, okay? If this was just geometry, some design changes or some construction problem in actual construction happened, and that's not gonna exactly same, okay? Because of some actual problems on site. Anyway, one example done by BIM Technologies, and second one, Korea Navy Museum. Take a look. This non-uniform shape already designed by Maya and Rhino, okay? So this is geometric shape, just the geometric shapes sketch at the beginning of the project. But this shape can be imported into Revit, okay? In Revit, designers can put some control vertices in order to edit this triangular shape for the building surface. And then in actual construction, on-site workers can figure out this triangular shape of this building skin facade can be manufactured, delivered to the site, and where to install this part, okay? This is part and assembly approach we roughly reviewed in parametric modeling approach in BIM, okay? Take a look, the last one, Plaza Hotel located in front of Seoul City Hall. This is before, okay? Very typical building facade for these hotel rooms. This is under the construction scene. There is a roughly visualized preview, and this is after, okay? Actually, it's not easy to figure out one single panel, one single component for one single Windows system. They all different, okay? Take a look this one. The 4 points thickness depths geometry has different dimension. So if you see this one, you can find out it has some different thickness or depths, okay? If this one, I'm not sure the number of this one, but estimately around, if this one has 200 systems, total 200 different modules, okay? So all they supposed to be precisely manufactured and delivered and to be installed, okay? So without BIM or parametric modeling technologies, this one going to be really, really hard work on site, okay? Because no one knows which part going to be installed where, okay? But thanks to this kind of parametric modeling and BIM approach, successfully done, okay? Like this way. Actually, I'm not talking about the impact of this design, whether this design is good or not, but anyway, different window system, different frame system, all totally different, manufactured at factory, transported and installed, okay, in order, thanks to parametric modeling and BIM technologies. Also, interior of this hotel, totally renewed, okay, remodeled. Also used BIM technology, okay, even 5 years ago, okay, done by Gansam Architects and some other companies. Okay, that's what happened. Just the tiny cases we can take a look. Let me show you another very old and typical project done by United States, an early pilot project using BIM, okay? This is one of the training building, kind of school-like, very simple structure building, okay? Very commonly found building structure in the United States. Almost more than 10 years ago, okay? But this building, take a look, it's floor plan, just rectangle shape, okay? If you are interested in early phase of architectural design, our focus was on just geometric shape of this building, just rectangle shape, okay? 2-3-story building, that's it. And some interior. But I told you before, BIM is in charge of entire building life cycle, from planning until demolition of this building, including several decades of maintenance, management. So interior design or conceptual design, design development, it's really tiny part of life cycle. How about construction? How about mechanical system, plumbing system? Installing such building systems, just tiny part of entire building life cycle. How about maintenance? Maintenance people supposed to be well known to mechanical system or any other building systems. So in terms of building information, BIM is in charge of entire building life cycle. So even if you are just designer, or even if you are interested in only for interior design or structural design, BIM tools in charge of entire building life cycle. So in this process, you can find out structural elements, structural foundation, MEP system, HVAC system, and so on, interior features, and so on. So exterior walls can be visualized like this one, planned, okay, and some structural foundation and H-beam columns, okay, for sustaining the structure of this building. And they can be connected by those, using those beams. Additional truss for ceiling structure and first floor's interior walls and some interior columns, and take a look, mechanical system, so-called MEP system. MEP system means mechanical, electrical, and plumbing, okay? And HVAC system, HVAC system means heating, ventilation, and air conditioning. Without such systems, building cannot run, okay? Walls, columns, slabs, furniture, that's not the end of building design. Amount of such systems usually going over ceiling structure, okay? So when you see open ceiling system, open ceiling room, you can find the amount of pipelines or mechanical systems installed. They are all controlled by some mechanical room or other facility equipments and so on. They all controlled by this kind of BIM tools without any problem. So at the around 10 years ago, Revit has separate versions. Autodesk Revit architecture, that was design tool, okay? And Autodesk Revit MEP, mostly in charge of building systems. Also another one, Revit structure. Revit structure in charge of structural modeling and analysis for kind of structural system of the building. Load-bearing walls, load-bearing columns, that's their major topic when they use such tools. And they all integrated into Revit architecture or Autodesk Navisworks, another system supporting BIM tools. Okay, anyway, second floor's entire interior walls and doors subcomponents. So truss system for rooftop and final roof object can be installed. The visualization is not that fancy. This is just axonometric view, but isometric view, but this one contains lots of information compared to photorealistic design specific model. Design specific model doesn't care any of this truss structure or sustaining structure, load bearing system, MEP, HVAC system, only deals with interior walls and design features, but actually this one doesn't have interior design features or interior components, furniture. But anyway, even much rich information, lots of information added on top of this single BIM model, okay? That's the point. So this pilot project simply shows you some longer and broader scope of building life cycle than schematic design or interior design. So we need to know this kind of process. Another review about Autodesk Revit. Its BIM approaches and use scenario for interiors. Okay, as of 2016 is the latest version, but in general, in May or even April, next year version going to be released officially. So Revit 2017 probably going to be released next month or in May. But anyway, our scheme in this semester, this course, we're going to use Revit 2016. Another one. How about Revit 2025? 10 years from now, 9 years from now. That Revit going to have auto design tool, okay? If you open empty Revit file and you just type, okay, new Starbucks branch located Seoul, Seongdong-gu, and area estimate 100 square meters, and users, target users, young people, and then Revit going to make auto design, just for your information. And what you need to do is adjust. And how about decoration? Okay, I like to put yellow colored flower-like structure in very simple and modern style, and click, and then such geometry components going to auto-created in Revit environment, thanks to machine learning and AI techniques. And I'm the one of developers for researching and developing such tools in the future. But anyway, computer cannot determine or make final decision, and computer doesn't have any responsibilities. Thanks to that fact, still designers, architects needed, because you have responsibilities for your design. Anyhow, even if such easy to use tools are available to public, you have to know the mechanism, and you have to customize, and you have to design easier and in convenient way, but at the end you have to determine the final decision and take responsibilities for your design. That is why you need, even if Revit 2025 has such very advanced artificial intelligence features. Anyway, today lab exercise we're gonna use this one, and in my belief, today's lab exercise, 1.5 hour lab exercise, that's enough for learning Revit, because Revit is easy to use. So you can design anything based upon today's lab exercise. Anyway, interfaces we reviewed before. This building, level 5, AutoCAD drawing will be given to you. You already copied, okay? So what you need to do is open Revit, import CAD file, and draw walls, doors, placing windows, only using given components, not custom object. You don't need to download or create anything, just to use existing library. And then you can make this kind of structure today and next week for the lab exercise, okay? These are the interface we reviewed before. One thing you need to remember is the location of template or library. On the C drive, there is program data. This is usually hidden folder. So you have to unhide hidden folders in your folder option, okay? If your computer doesn't list up program data folder. Under program data, there is Autodesk and Revit 2016. Under this folder, you can find out template, library, and so on. Under library, in current installation, we have amount of Korean libraries and generic libraries. If you want to install US metric library or even French, Hungarian library, you can install. Just double click again, Revit installation, and then Revit installation will ask you to add library or not. So you can simply add libraries, okay? Several gigabytes, so it's up to your decision. But so far we have amount of Korea library, so we're gonna use that. So this is the interface we already reviewed. We're gonna do that again in lab exercise, and the mechanism. Another thing you need to know is this is dynamic interface. It has dynamic interface. That means if you select something or click something, new ribbon interface will be popping up like this. Okay, if you click door, this one will show you something about doors and modification for doors, okay? So whatever you want to do, don't just look at screen, just click or doing something, and then this one will display you for further work, okay? Property windows, project browser, we already reviewed. Let's take a look some key features of Revit. Firstly, you can export building geometry in DWG, DWF, FBX. FBX contains Autodesk material, texture. So you don't need to texture again and again in 3D Max. You can render without any additional efforts. Anyway, exporting geometry is okay, and also vice versa, importing geometry. Revit supports amount of diverse kind of geometry versions, formats. It can import almost everything. And also exporting building information model in IFC format. IFC is one of the file format, okay? Neutral file format. So you don't know ArchiCAD. You don't know Bentley systems, but you know Revit. but your collaborator working with ArchiCAD, and you need to export exterior surface system of your building design. Just you can export IFC, not DWG. DWG contains only geometry, but this one contains properties, information, parametric data, okay? So your BIM model can be exported through IFC and imported into another BIM tool. What happened? He knows your door object, wall object, corner system object, not just geometry, okay? So this is another important thing, but in undergraduate level, we're not going to deal with IFC format. Instead, I'm going to show you some example cases. I told you before, some cuts in architecture, space-oriented approach. We are dealing with space. But in CAD system, there is no way to define space. There is a way to define walls, bounding walls. And then we can recognize that inside of bounding walls going to be going to be space or room. But in Revit, there are space objects, such as rooms, floors, zone, and so on, area. Also mass object, okay? Even if just a simple box shape, that is a mass object, okay? You can divide the mass for levels, and you can edit that mass to specific building design, okay? And also space object, auto-determine the boundary of space. And you can assign space object. And then you can get the area of space, height of space, how many spaces, how many rooms in your building. Revit can count instead of you, okay? Very smart. And also, how about 2D plans, 2D drawings, 2D draftings? You don't need to take care of them, okay? Floor plans, elevation sections, 3D views, rendering, any type of industry standard or subject of auto-generation, okay? You don't need to take care of such views. Of course, you need to take care of some notation, additional notation or some frames and your text, but that's it. Drawings from model auto-generated in auto-updates. Building modeling objects and geometry in advanced parametric modeling technologies. I told you what is parametric modeling. Thanks to parametric modeling, whatever you create, all your projects going to be managed by parametric way. In other words, smart way, okay? Supporting .NET-based plugin development. Actually, this one is something for developers. .NET means Microsoft programming environment, such as C# language, similar to C language, okay? And also, I told you before, usually conventional CAD tools are very powerful for visualization, but I think Revit is much better than other tools in terms of visualization, photorealistic rendering, or this one supports walkthrough video making, okay? Video file, very easy to create. Just save video walkthrough. What you need to do is working paths. And this one will generate animation of walkthrough animation. And bird eye view or any type of 3D view, realistic rendering or line drawings, perspective, isometric, whatever it is, it supports various and diverse kinds of visualization styles. So those are mass object. Another mass object defined by levels and interferes with corner system. Actually very easy. Design from mass. When you design a building, usually we get started from building mass. Cut building mass, distorting building mass, doing something using that building mass. Same way, okay? In building, you can create building mass first and modifying, just like a sculpture, okay? Same way. And also this is space object. You don't need to do lots of things. What you need to do is simply click room and mouse over the room and then take a look, these blue lines. auto-detected boundary of this room, okay? Auto-detected. Just simply click it and name the room, that's it. Render example, another render example in terms of visualization, and FBX file or geometry-based render using Revit model and 3D Max visualization. But Revit render is kind of exceptional when you use Revit render tools capability like this way.